The typical type of problem or exercise that you'll be working in this course is one that's going to be focused on data. What the heck do we do with a whole lot of data that has been collected? What you see on screen here is out of your Montgomery and Runger text, and that is that we have a set of 80 samples of a new aluminum lithium alloy that have been tested for their compressive strength. And we've collected all those results, and now what do we do with all of them? That's a lot of numbers to be carrying around. And of course, we typically aren't interested in those specific individual values, but we'd like to know something about what the aggregate tells us about something. And so that's really what I want to get to here, are what the typical kinds of questions are that we might be looking at and trying to deal with. So we've got these compression tests, our sample size, or the number of tests that we've conducted, is 80. And of course we typically use the symbol lowercase n to indicate that we have those, the size of that test. And the questions then end up forming are of many fold. Some of the most direct ones are, how do we summarize the data and do so in a meaningful way that is of significant assistance to us? Or what model could be developed? Some instances we don't have a mechanical model developed yet, and so that might be one of the questions that we can do. But really, what model could be developed, and really what we're trying to get after is not so much the model of that specific data sometimes, but really rather of the entire population. So notice we're making a differentiation between this subset of the population of 80 samples versus all of the entire population of this new aluminum lithium alloy. How might we compare this material with others? If it's a new material, then how do we know whether it's, quote, better or not? And what are the key aspects of that? When we get into hypothesis testing, we'll be talking about some of this comparisons that could be done. Or it might be the case that this is a new manufacturing process for this specific material, and we're going to compare the new process and the results of that to the previous one. So it's not just about comparing materials, this might be comparing processes as well, and any other kinds of variations or changes that we might be making. How do we make those comparisons in not subjective ways but more quantitative ways, so that the conclusions are not sensitive to the preferences of an individual, whether that's an individual person or individual organization. Right? Other aspects here are how to quantify our confidence associated with our analyses. Right? And in many ways what we're really trying to do is create this objective procedure, one where you and I would look at the data and process it and come to a similar conclusion because we're using the same process, sort of a standardization approach. And when we communicate the results then and we say, well, I have a 95% confidence, what exactly does that mean, is the critical question there. And then another typical kind of question is, what about outside the range of the observed data? Do we have potential for the population to be outside of what we've observed? And if so, what do we do about that? Or maybe we want to try to predict something outside of the range of our data. Can we do that? Can we use that? And so there's a bottom line aspect to all of this that we want to drive at in this Archtype kind of problem. And that bottom line that we're going to be addressing is, how can we use the observed and presumably random sample to understand attributes of the entire population. And we'll be developing specific techniques to help us to be able to do that.